Okay, chapter 11, review for college algebra. We're going to start with this first problem. It says determine whether the function is 1-to-1. If it is, find a formula for its inverse. So if a function is 1-to-1, it will pass the vertical and the horizontal line test. So I'm going to put this in y equals. It says 5x minus 1. I'm going to graph it. It passes the vertical line test in that a vertical line would not touch it twice as I moved it across. It passes the horizontal line test in that a horizontal line would not touch it. So it is 1-to-1. Now to find its inverse, I'm going to take the function f of x is 5x minus 1. I'm going to write it as y equals 5x minus 1, and then I'm going to swap x and y. Then I'm going to solve for y. So this is, hello. So I'm going to have x equals 5y minus 1. Add 1 to both sides. X plus 1 is 5y. Divide by 5. Y is x plus 1 over 5. So that is your answer. Okay, the next one, number 2. I'm going to put that in my calculator. It says x plus 5 to the 1/2 power. It's the square root of that. I could have put it in this way. I could have said second square root of x plus 5. Either way, I'm going to graph it. And a vertical line will not touch it twice, neither will a horizontal line. So yes, it has a inverse. Yes, the function is 1-to-1. So I'm going to take it. It's g of x equals the square root of x plus 5. I'm going to write it as y equals the square root of x plus 5. I'm going to swap x and y. X equals the square root of y plus 5. Then I'm going to solve for y. When doing that, I'm going to square both sides. So I have x squared equals y plus 5. Then I'm going to subtract 5. So x squared minus 5 is y. That is my inverse. Okay. Number 4 says 7 to the x power is 49. And they want us to solve for x. To do that, they want you to write this with the same base. So it's 7 to the x equals 7 squared. So x equals 2. Number 6 is the next one I'm going to work. It says 16 to the 3x minus 6 power equals 64 to the x plus 4 power. Now both of these could be written as powers of 4 or powers of 2. I'm going to drop it back to a power of 2. 2 to the 4th is the same as 16. And 2 to the 6th is the same as 64. And then what I'm going to need to do is multiply here. So it's 2 to the 12x minus 24 equals 2 to the 6x plus 24. Then you can take your exponents, set them equal. I'm going to subtract 6x from both sides. 6x minus 24 is 24. I'm going to add 24. 6x is 48. Divide by 6. X is 8. The next one I'm going to work is 7. It says 20 to the x power equals 0.05. Now, log How do they write it? What do they use x and y and a. I have it in here in my notes. Let me find it. I don't want to do it the wrong way. Let me just make an example up. 3 squared is 9. Everybody knows that. So log base 3 of 9 equals 2. And what we did was we took the 3 and we drug it over and it picked up the 2. And so 3 squared equals 9. So this was log of something equals something. Now, here's the way I do. 20 has an exponent. So 20 had to be what started here. The exponent was here. 0.05 went here. And we're supposed to find the answer to that. So you can go to your calculator. You can turn it on. You can go math. And you can go all the way down to log base. And you can enter 20 to 0.05. And that answer is -1. That was go into math and all the way down to log base. And it'll let you enter those. Number 10 says log base of x of 1/16 equals -2. So I'm going to drag that over. X to the -2 power equals 1/16. Well, I know that negative exponents mean to put things in the bottom. So this is 1/x squared equals 1/16. So now I see that x has to be 4. Number 12 says log base 2 of 5x plus 2 is 5. So 2 picks up the 5. 2 to the 5th is 5x plus 2. 2 to the 5th power is 32. So 32 equals 5x plus 2. Subtract 2. 30 equals 5x. Divide by 5. X is 6. Okay. Log 3 of the cube root of 5 over q squared z. The first thing that I would do is I would write this as log base 3 of the cube root of 5 minus log base 3 of q squared z. So I've split apart that fraction because I know that division translates into subtraction. Then I would write this as log base 3 of 5 to the 1/3 power minus, I'm going to split this. Multiplication translates into addition. So this is log base 3 of q squared plus log base 3 of z. Now, the next thing I'm going to do is I'm going to bring that 1/3 over here. 1/3 log base 3 of 5. I'm going to distribute minus log base 3 of q squared minus log base 3 of z. I have one more thing to do. Take that 2, put it here, because it's the exponent comes over as a coefficient. 1/3 log base 3 of 5 minus 2 log base 3 of q minus log base 3 of z. Okay, number 16 asks you to put it back together. This is the problem, 4 log a of 4 minus 3 log a of 3. So the first thing I'm going to do is I'm going to put this 4 back here and the 3 back here. So this is log base a of 4 to the 4th minus log base a of 3 to the 3rd. Now that's log base a of 4 to the 4th over 3 to the 3rd, because subtraction translates into division. When you use those exponents, this is log base a of 256 over 27. Okay, this is Chapter 11, Study Guide, Part 2, starting with number 18. It says, you know that the log of base 10 of 49 is 1.6902. Find log base 10 of 7. Well, we know that log base 10 of 49 to the 1/2 is equal to log base 10 of 7, because the square root of 49 is 7. 49 to the 1/2 is really the square root of 49, which is 7. So I can pull this over and I can say, well, that's equal to 1/2 log base 10 of 49. So that's 1/2 of 1.6902. And when I do that, I get 0.8451. Okay, number 20 asks us to find the value of x, and we're going to do that by taking the log of each side. Log of 3 to the 2x is equal to the log of 17. Then I can pull the 2x over. 2x times the log of 3 equals the log of 17. Divide by the log of 3. 2x equals, put this in here, log of 17 divided by log, let me close my parentheses, log of 17 divided by log of 3. So 2x equals 2.5789 divided by 2. X is equal to 1.2895 when you round. 22. Says log x plus log of x minus 15 equals 2. So what we'll do here is those are both base 10, and we know that addition translates into multiplication. So log base 10 of x times x minus 15 equals 2. Pull the 10 over. 10 squared equals x times x minus 15. 100 equals x squared minus 15x. 0 equals x squared minus 15x minus 100. I can factor that. Factors into x minus 20 and x plus 5. So x minus 20 could be 0, x plus 5 could be 0. So x could be 20 or x could be negative 5. But we know that it can't be negative, so my answer here is x is equal to 20. Number 23 asks you to use this formula, A equals P times 1 over R over N to the NT. So there's my formula. I'm going to put that in my calculator. Hope that works. I hadn't tested this one beforehand. 1 plus, open another set, 0.07 divided by 4, close them, raised to the 4 times 7 power. I get, I'm off by 1 decimal. Oh, there's this. Let me do it again. 12,000 times 1 plus, open parenthesis, 0.07 divided by 4 to the 28 power is 19,504.95. That's 23. Here's 24. It's a PERT formula. So we start off with the amount, $1,550. And we don't know what the principal is, but we know that we're leaving it in there for 20 years at 0.065 interest. So you've got to divide both sides by E. There's an E button on here. It's a second natural log. E to the power of 0.065 times 20. And I get $422.42.